Welcome to the final part of 99 problems. I hope you've found this paper useful so far. Let's go ahead and finish it off. So question 81 is what we're up to. Question 81 says the two numbers a and b are shown on a scale. The difference between a and b is 48. Work out the value of a and the value of b. So we're given the distance between these, and we're going to have to count the number of regular intervals between those and then divide 48 by that number. So we've got 1, 2, 3, 4, 5, 6 intervals. So there's going to be 6 lots of something. 48 divided by 6 is 8. So therefore each interval is 8. So we'd be going up by 8 here. So 8, 16, 24, 32 to get to B. And counting back to A, we'd have -8 and then -16. So A is going to be -16 and B is going to be 32. On to the next one. Oh, that was 3 marks for that question. 82 says a sofa has 6 identical cushions. Each cushion is a cuboid 8 centimeters by 80 centimeters by 95 centimeters. The cushions are covered with a protective spray. The protective spray is in cans. The label on each can has this information. Spray in this can covers 4 meters squared. And part A of this question asks, work out how many cans are needed to cover 6 cushions with protective spray. This is going to involve working out the surface area and also converting between square centimeters and square meters, because you notice the measurements for the cushion are in centimeters and the measurement for the spray is in meters squared. So this surface area we're going to work out in centimeters squared. We're going to convert that to meters squared. So let's go ahead and firstly work out the surface area of one cushion. So to work out the surface area of a cuboid, we work out the surface area or the area of each face. And because there's 2 of each face, we multiply that by 2. So the surface area is going to be 2 lots of this face here. The dimensions of this face are 95 and 18. So this will be 95 times 18. Plus this face here would be 80 times 18. So 2 times 80 times 18. Plus 2 times the other face, which is the top here, which would be 80 times 95. So 80 times 95, and that should give us our surface area. Let's go ahead and put that into a calculator. So 2 multiplied by 95 times 18 plus 2 times 80 times 18 plus 2 times 95 times 80. And that gives us a surface area of 21,500, and that's going to be centimeters squared. So now, well, to convert that to meters squared, remember it's not the same as converting centimeters to meters. So the way I remember this is I think of a square meter, and I think how many square centimeters would be in that square meter. Well, if this is a square meter, it's 1 meter by 1 meter, and that's also 100 centimeters by 100 centimeters. So 1 square meter is going to be 100 times 100, 10,000 square centimeters. So that's how I remember that. So to convert from square centimeters to meters, I need to divide by 10,000. So 21,500 divided by 10,000 is going to be 2.15 meters squared, and that's the surface area of one cushion. Remember, the sofa has 6 identical cushions and we're trying to cover them all with protective spray, so the surface area of all of those cushions together would be 6 times this. So 6 times 2.15. Why not use a calculator? This is clearly a calculator question. 6 times 2.15 and we get 12.9. So all up, all of the cushions have a surface area of 12.9 meters squared. So how do we figure out how many cans we need to cover that? We can divide that by 4 because each can covers 4 meters. So then 12.9 divided by 4, and I already know it's going to be more than 3. We could get an exact number, so let's go ahead and do that. Divide by 4 and we get 3.225. It doesn't really matter because if it's over 3, then we're going to need 4 cans automatically. You can't cover that extra 0.225 with only 3 cans. So as long as I know that that's over 3, then I know that I need 4 cans. So my answer here to answer the question, how many cans are needed? That's going to be 4 cans for a final answer there, and that's 5 marks. So I would say for those 5 marks, you would need all of that working out, showing that it's over 3 for the number of cans. Next question says the information on each label is inaccurate. The spray in each can covers 10% more than 4 meters squared. How will this affect the number of cans needed for the 6 cushions? You must show how you get your answer. So if it covers 10% more than 4 meters squared, well, 10% of 4 is 0.4. So then it would cover 4.4 meters squared per can. So remember that we needed the cans to cover a total of 12.9 meters squared. So could I cover that now with only 3 cans? Well, let's do 4.4 times 3. 4 times 3 is 12. 0.4 times 3 is 1.2. So this would be 13.2 meters squared. And that's greater than 12.9. So now we can see that 3 cans would be enough. It would cover more than the surface area we had. So therefore now we only need 3 cans. So let's go ahead and write that down. So how would it affect the number of cans? The number of cans is reduced. So the number of cans is reduced to 3 for 2 marks. That was question 82 for a total of 7 marks. On to 83. The diagram shows a tank in the shape of a cuboid. It also shows a container in the shape of a cuboid. The tank is full of oil. The container is empty. 35% of the oil from the tank is spilled. The rest of the oil from the tank is put into the container. Work out the height of the oil in the container. Give your answer to an appropriate degree of accuracy. Right, so here's the container. This is full of oil, and if 35% of it has spilled, that means 65% of it has poured into the container. And we want to work out the height of oil in the container once we've poured all of the oil in there. So firstly, we can work out the volume of oil by working out the volume of the tank and then working out 65% of that. And then we're going to be able to use that value to work out the height in the container. So let's firstly go ahead and work out the volume of oil. So the volume for the tank is all of the dimensions multiplied together for a cuboid. So 60 times 50 times 40 gives you the volume there. And 60 times 50 times 40, let's go ahead and work that out. So you might already know what it is, but let's see. 120,000. So that's the total volume of the tank here, centimeters cubed. And again, 35% of the oil spilled, so we have 65% of that. So 65% of this would be 0.65 multiplied by 120,000. Multiply that by 0.65, we get 78,000. So now we have the volume of oil, 78,000 cubic centimeters. So how are we going to use that to work out the height here? Well, if we know that the volume is going to be 78,000, it's going to be somewhere, in this tank. How do we work out the volume? We do the height times the length times the width. Now, basically we're using an equation here. We're saying we're using an unknown, h times 80 times 70 equals 78,000, and then we can solve that for h. So let's go ahead and create that equation. H times 80 times 70 equals 78,000, and then h is going to be 78,000 divided by 80 times 70. 80 times 70, that's going to be 5,600. So 78,000 divided by 5,600 will give us our height. So 13.92, and it says give your answer to an appropriate degree of accuracy. Now that's referring to the fact that all of these measurements are both whole numbers and multiples of 10. So looking at the lengths of the tank, we could either round this to the nearest whole number, I think that would be appropriate, so 14, or the nearest 10, which would be 10 centimeters. So I'm going to round it to 14, the nearest whole number, but 10 would also be appropriate there. Okay, so for that height, my answer, well, let's firstly write down the non-rounded number. So that was 13.928 and so on. And my final answer is going to be 14 centimeters. And that was question 83 for 5 marks. On to 84. 84 says the total weight of 3 tins of beans and 4 jars of jam is 2,080 grams. The total weight of 5 tins of beans is 2,000 grams. Work out the weight of 1 tin of beans and the weight of 1 jar of jam. Well, we can use this information here to work out the weight of 1 tin of beans. So it tells us 5 tins is 2,000 grams. So therefore 1 tin of beans is going to be 2,000 divided by 5. So 1 tin of beans equals 2,000 divided by 5, 400 grams. And then use that information for the first bit of information here. 3 tins of beans and 4 jars of jam is 2180. So 3 tins of beans would be 3 times 400 grams. So that would be 1,200 grams plus 4 jars of jam. Now we don't know that yet, but we're going to be able to figure it out. So 4 jars equals 2080. So now we know that 4 jars of jam will be 2080 take 1200. So that's 4 jars, and then this equals 2080 take 1200. That's 880, and then dividing that by 4, so that's 4 jars again. So 1 jar is going to be 880 divided by 4, that's 220. So 1 jar of jam is 220 grams and 1 tin of beans is 400 grams for my final answers there. Okay, that was question 84 for 4 marks. Question 85 says, Asif is going on holiday to Turkey. The exchange rate is £1 to 3.5601 lira. Asif changes 550 pounds to lira. Work out how many lira he should get. Give your answer to the nearest lira. If we have 3.5601 lira for every pound, then we need to multiply 550 by 3.5601 to get the amount of lira we have. So let's go ahead and do that. 550 multiplied by 3.5601, and I get an answer of 1958.055. And it says give your answer to nearest lira, so this is going to be 1958 lira. Okay, part B says Asif sees a pair of shoes in Turkey. The shoes cost 210 lira. Asif does not have a calculator. He uses £2 equal to 7 lira to work out the approximate cost of the shoes in pounds. Use £2 equals 7 lira to show that the approximate cost of the shoes is £60. So to do this conversion, you could do 210 divided by 7 and then multiplied by 2. So 210 divided by 7 is 30. 30 multiplied by 2 is 60. So the approximation there is £60. And part C says, is using £2 equal to 7 lira instead of using £1 to 3.5601 lira a sensible start to Asif's method to work out the cost of the shoes in pounds? You must give a reason for your answer. I would say yes, as 7 is a good approximation to 2 multiplied by 3.56 if you're trying to do it in your head. So that would be my answer there. So yes, as 7 is a good approximation for 2 times 3.56. And that is question 85 for 5 marks. Question 86 gives us a cafe price list, and it says Dylan and some friends went to the cafe. Dylan bought himself a cup of tea. He bought each of his friends a cup of coffee. He paid with a £10 note. He got 4.61 change. How many friends were with Dylan at the cafe? Alright, a fairly straightforward arithmetic question here. Let's firstly work out how much he paid. So he got 4.61 change. So 10 take 4.61 is 5.39. So he paid, let's do the working out. Let's show the working out. 10 take 4.61 equals 5.39. And then he bought himself a cup of tea and everyone else had a cup of coffee. So let's subtract 65p from that. So 5.39 take 65p. I should represent that as a decimal actually. And what do we get for that? Well, why not just whack it into a calculator? So 5.39 take 0.65 is 474. And then if each friend had a cup of coffee, let's divide that by the price of the coffee, which is 79p. So 4.74 divided by 0.79, and that will give us the number of coffees he bought. So 0.79 divided by 0.79, we get 6. So therefore he bought 6 cups of coffee. So how many friends with Dylan at the cafe? 6. 4 marks there for question 86. On to question 87. Here are 2 rectangles, rectangle A and rectangle B. All measurements are in centimeters. The area of rectangle A is equal to the area of rectangle B. Work out the perimeter of rectangle B. Okay, so firstly they tell us the areas are equal. So let's firstly come up with an equation that relates the 2 areas. So the area of A will be the length times the width, 2.5 multiplied by 4x. And the area of B, also length times width, 7 times 2x, take 3. And these are equal. So they are going to equal each other. And this gives us an equation that we can solve for x. Once we come up with a solution for x, then we can work out the perimeter. So let's go ahead and solve this. 2.5 times 4, that's 10. So 10x on the left-hand side. Let's expand out these brackets. 7 multiplied by 2x, 14x. 7 times negative 3 is negative 21. And then subtract that 10x from the right-hand side. 14x take 10 is 4x. And I would add that 21 to the other side, so we'd have 4x equal to 21. I took a couple of steps there. Hopefully you can follow those. If you need extra steps with your algebraic working out, that's totally fine. Make sure you're understanding the process. So if you need extra steps in there, please take them. Then 21 divided by 4, that's going to be, 20 divided by 4 is 5, and then we'd have a quarter. So this is going to be 5.25 or 5 1/4. Okay, so we have a value of x. So now let's have a look at the rectangle B. The perimeter of rectangle B is going to be 2 times x, take 3, will be the width here. So x was 5.25, take 3. 2 times 5.25 would be 10.5, take 3. So this length is going to be 7.5. And then the perimeter is going to be 2 lots of 7.5 plus 2 lots of 7. So let's go ahead and write that down. So the perimeter of B is going to be 2 times 7.5 plus 2 times 7. That's 14 plus 15. That's 29 centimeters, because they tell us all measurements are in centimeters. So final answer there, 29 centimeters for 5 marks for question 87. Question 88 says, in triangle RPQ, RP equals 8.7 centimeters, PQ equals 5.2 centimeters, and angle PRQ equals 32 centimeters. Assuming that angle PQR is an acute angle, calculate the area of triangle RPQ. Give your answer correct to 3 significant figures. Okay, I need to draw a diagram for this question. So firstly, let's do RPQ. And I guess they could be anywhere, it doesn't really matter. So firstly a triangle, and then RQP, and RP will be 8.7, PQ is 5.2. Okay, this is not to scale, but that's fine. Angle PRQ is 32 degrees. And it says, assuming PQR is an acute angle, calculate the area of triangle RPQ. So I guess the other case would be, so this has to be 32. The other case would be, it could be out here. So it could be like this. And this would still be 8.7. And this would still be 32 in here. The only thing that would change would be this angle PQR. So we're assuming it's acute, so we're taking this one, but the other case would be if it's out here, so that would be obtuse. Okay, anyways, calculate the area So we don't have the height or the base, but we could use half AB sine C if we had the angle between these two sides. So when we use this formula for the area, these A and B, these are the sides adjacent to this angle C. So if we can work out that angle, then we can use this formula to work out the area. To get that angle, I could either work out this side or this angle. I think the most efficient method would be to work out this angle and then work out this angle. And I can work out this angle using the law of sine. So let's go ahead and do that first. So this is the angle I'm looking for. So sine theta over 8.7, the opposite side, equals sine of 32 over the opposite side to angle 32, which is 5.2. That's the law of sines. Let's go ahead and solve this for theta. So theta is going to be the inverse sine of this multiplied by 8.7. So let's go ahead and put that into a calculator. So inverse sine of 32 divided by 5.2 multiplied by 8.7, and I get 62.4485 and so on. So 62.4485. So now we have this angle, we can work out angle RPQ. So let's go ahead and do that. So angle RPQ, this would be 180 take 32, take this angle, and let's put that in. So 180 take 32, take that answer, and I get 85.551 and so on. And then, as I said, now we have this angle in here, we have the two sides adjacent to that angle. We can use this formula half AB sine C to get the area. So let's say area equals half AB sine C equals half times A 5.2 times B 8.7 times the sine of 85.551, and let's see what we get for that. So 0.5 times all of this, and I get 22.55 and so on. And the question said round to 3 significant figures. So to 3 significant figures, that would be 22.6. Okay, so just write the unrounded number and then 22.6 as a final answer. And that was 4 marks for part A. Part B says, if you did not know that angle PQR is an acute angle, what effect would this have on your calculation of the area of triangle RPQ? Well, I kind of hinted at that at the start of going through part A. There would be another angle to consider, or another triangle to consider, with this obtuse angle. So there are 2 possible triangles with these dimensions or measurements. So this could still be 8.7 and this could still be 5.2 and 32 degrees here, but this angle would then be obtuse. So what effect would this have on your calculations? Well, we would also have to consider this triangle, which would have a different area. So what would we be doing? We'd be calculating the area of 2 different triangles. So for part B, I would say there would be another triangle to consider. So we would therefore be calculating the area of 2 triangles. So angle PQR could be obtuse also. So therefore we would need to find the area of 2 triangles for 1 mark. And that was question 88 for 5 marks. Question 89 gives us a fairly simple right angle triangle, and it says A is 8.3 centimeters, correct to the nearest millimeter. B is 6.1 centimeters, correct to the nearest millimeter. Calculate the upper bound for C. You must show your working. Okay, so let's write the error intervals for each of these measurements first. So if we round it to the nearest millimeter, we need to add on an additional digit on these numbers. So, and another way to think about this is to draw a little number line. If you struggle with this, and add an extra digit on there. So we have 8.30 as our current measurement, or what we're rounding to, and it's always rounding to the nearest 10. Once you add that on, think of this as 30, and what rounds to 30 to the nearest 10? Well, it's 25, so 8.25. And what rounds down? Well, it's anything less than 8.35 or 35 if you're just looking at those last two digits. So that's a strategy. Draw your number line in and try to think of it that way, rounding to the nearest 10 once you add that extra 0. Same for 6.1. So again, we're rounding to the nearest millimeter, which is the first decimal place. So think of this as 6.10 or 10 for our last two digits. So then the lower bound is going to be 5, so 6.05. And the upper bound will be, if you're just looking at the last two digits, the upper bound will be 15, so 6.15. So if we're to write this as an error interval, we would say A is greater than or equal to 8.25 centimeters and less than 8.35 centimeters. Make sure you get those inequality symbols correct. It's always greater than or equal to and less than, because 8.35 does not round to 8.3. Okay, for B, we have the error intervals of 6.05 and 6.15. Okay, then let's think about how we would get the upper bound for C. So how would we maximize C? Well, firstly, how do we find C using these two? We use Pythagoras' theorem, which says a squared equals b squared plus c squared. So then c squared is a squared take b squared. How would we get the maximum value of C? Well, A would have to be its largest value and B would have to be the smallest possible value of B. Then we would get the largest value of C. So taking the largest possible value of A, we would have 8.35 squared, subtract the smallest value of B, 6.05 squared, and now we just have to calculate. So 8.35 squared, subtract 6.05 squared, and then take the square root of that to get C, and I get 5.75 and so on. So that will be my upper bound for C, 5.75. And what should we round off to? It doesn't say what to round off to, but if these are given to the nearest millimeter, then that's a clue that we should probably round this off to the nearest millimeter as well. So we should round this off to 5.8 centimeters. Okay, so that's going to be my final answer there, 5.8 centimeters for 4 marks for question 89. On to question 90, there are only blue counters, green counters, red counters, and yellow counters in a bag. Olga is going to take at random a counter from the bag. The table shows the probability that Olga will take a blue counter and the probability that she will take a yellow counter. The number of red counters in the bag is 4 times the number of green counters in the bag. Complete the table. Okay, let's firstly add these up. So blue plus yellow is going to be 0.55. So I'm going to show all my working out here. Blue plus yellow equals 0.55. Therefore, green plus red equals 0.45, because all of these probabilities need to add up to 1. And so we know these add up to 0.45 here. And we also know the ratio of red to green counters is 4 to 1. So red to green equals 4 to 1. So we could treat this like a ratios question. How many parts in this ratio? There's 5 parts. So what would one part of that ratio be worth in terms of this probability? Well, we need to do 0.45 divided by 5, the number of parts in the ratio. So 0.45 divided by 5, it's like 45 divided by 5, 0.09. So then one part of this ratio is worth 0.09, and that related to the probability for green counters. So for green, we've got 0.09, and for red then we've got 4 parts of that ratio. 4 times 0.09 would be 0.36, and then to double check, make sure these add up to 0.45 and they all add up to 1. So 36 plus 9 is 0.45 and they will all add up to 1. So there we go. That was question 90 for 3 marks. Question 91 says Eric and Geraldine both drove from town A to town B. This question looks familiar actually. I think this is from the 2017 exams. But anyways, they both drove from town A to town B. Both Eric and Geraldine left town A at 2 p.m. Eric drove on route 1. He got to town B at 2:48 p.m. Geraldine drove on route 2. She got to town B at 3:25 p.m. Who drove at the greater average speed? You must show all your working. So for this, we need to know that average speed equals distance over time. So for Eric, he drove on route 1. He's driven a distance of 36.4 miles and he left at 2 p.m. and he arrived at 2:48 p.m. So therefore he's taken 48 minutes to drive that distance. So Eric's speed is going to be his distance 36.4 divided by 48. And be careful with your answer. If you leave this in minutes, you're going to have a speed of miles per minute. Now, to answer the question, who drove at the greater average speed, I think that's fine to get an answer in miles per minute. You can still compare them, but just be aware if it said find the average speed in miles per hour, then you should convert this to hours first. Anyways, let's do this calculation. So 36.4 divided by 48, and we get 0.758 and so on. And that's, as I said, miles per minute. And then for Geraldine's speed, she drove route 2, which was 65.2 miles, and she left at 2 p.m. and arrived at 3:25 p.m. So therefore she's taken an hour and 25 minutes. In minutes, that's 60 plus 25, that's 85 minutes. So her time, or her distance firstly, was 65.2 and her time was 85 minutes. So let's put that in. So 65.2 divided by 85, and we get 0.767 miles per minute. And now they're both in miles per minute, so we can compare them. Eric's speed less than Geraldine's speed. So to answer the question, who drove at a greater average speed? Geraldine drove at a greater average speed. So let's just go ahead and write that down. There we go. I'll try to find the timestamp of that question in the 2017 exams, and you can maybe compare how I answered it there. Okay, so that was question 91 for 3 marks. Question 92 says Redlands School sent X students to a revision day. St Samuel's School sent twice as many students as Redlands School. Francis Long School sent 7 fewer students than Redlands School. Each student paid £15 for the revision day. The students paid a total of £1,155. Work out how many students were sent by each school to the revision day. You must show all your working. For this, I'm going to set up an equation and solve that. And I want an expression that represents the total number of students that went to the revision day. So firstly, starting off with Redlands School, they had X students. And then St Samuel's School sent twice as many students. So that would be 2 lots of X. And then Francis Long School sent 7 fewer students than Redlands School. So that would be X take 7. So we need to add on X take 7. So that represents the total number of students. If each student paid £15, then we could multiply this total number of students by 15, and that should give us the cost. So this expression should equal 1,155. All right, now we have an equation that we can go ahead and solve for this unknown X. Firstly, divide by 15. That would be close to 80. So 1,155 divided by 15, 77. So let's go ahead and do that first. So on the left, well, we'll just leave this as is for now. So do it in a couple steps. And we divided by 15, which was 77. Now let's go ahead and simplify this expression here. So x plus 2x is 3x, plus another x is 4x, and that negative 7 stays as is. So we've got 4x take 7 equals 77. Add that 7 to the other side, so 4x equals 84, and then 84 divided by 4, that would be 21. So remember what x was? That was the number of students that Redlands School sent. So Redlands School sent 21 students, and remember the question said work out how many students each school sent. So let's go ahead and write these down. Redlands sent 21 students. St Samuel's, they sent, well, double the number of students Redlands sent. So 2 times 21 is 42. And St. Francis Long sent 7 less than Redlands. So that would be 21 take 7, 14. So Francis Long School sent 14 students. That is my final answer for question 92 for 5 marks. Question 93 says there are Y black socks and 5 white socks in a drawer. Joshua takes a random 2 socks from the drawer. The probability that Joshua takes 1 white sock and 1 black sock is 6 over 11. Show that 3y squared take 28y plus 60 equals 0. Okay, so to answer this question, we're going to have to set up a probability equation using this probability and this information they've given us. So what is this probability? It's a probability that he takes 1 white sock and 1 black sock. So how could we write that? Well, we could say the probability of, well, he could either pick a black sock first, then a white sock second. So black, then white. Or he could pick a white sock first and then a black sock second. They're 2 separate events there. So he could then pick a white, then a black. So they're the 2 possibilities here, and this probability equals 6 over 11. Now we have to think of a way of representing this using this information here. Well, firstly, what's the total number of socks we have? We have Y black socks and 5 white socks. So we have a total number of socks of Y plus 5. How could we represent the probability of picking a black sock? Well, that would be the number of black socks out of the total. So Y divided by Y plus 5. That's the probability of picking a black sock. Then if we want to find the probability of black and then a white sock, we need to multiply those. The probability of white sock is going to be 5 out of the total. However, once we've picked out a black sock, the total is going to change. We're going to have 1 less sock in the drawer, and we could represent that as Y plus 4. Okay, so for the probability of a white sock picking that second, that would be 5 over Y plus 4. And we need to multiply these together because we've got the probability of black and then a white. And we need to add on the probability of a white then a black. Use a similar logic here. This would be 5 over Y plus 5 multiplied by Y over Y plus 4. Again, you've taken a sock out, so we have 1 less in the total. And this equals 6 over 11. Okay, now we have our equation. All we need to do now is simplify this down to this form. So hopefully we end up with 3y squared take 28y plus 60 equals 0. The first thing I would do here is recognize these denominators are the same. So I would expand those out and then add the numerators. So we would have one big fraction here. In the denominator, we'll have y plus 5 times y plus 4. Let's go ahead and see what we get if we expanded those brackets out. We get y times y, which is y squared. 4y plus 5y is 9y, and then 5 times 4 is 20. In the numerator, we would have 5y plus 5y, which will be 10y, and all of this equals 6 over 11. Okay, next I would cross multiply. So multiply this by the denominator over here. So what I'm saying is multiply the denominator with the numerator on the opposite side. This is one way to solve algebraic fractions like this. So 6 times this and 11 times 10y. And I might put that quadratic on the left hand side. So this will be 6y squared plus 54y plus 120 equals 110y. And I could have divided through by 2 already, but I could do it here as well. So if I divide through by 2, everything by 2, so it's still equal, this would be 3y squared plus 27y plus 60 equals 55y. And then bring that 55y over to the left-hand side, so it'll become a negative. 27 take 55y. What's the difference between 27 and 55? That's 23 plus 5, 28. So this is going to be 3y squared take 28y plus 60 equals 0. And oh, that's what we were looking for. So it said show that 3y squared take 28y plus 60 equals 0. We've done that. So there we go. That was part A for 4 marks. Part B says find the probability that Joshua takes 2 black socks. Okay, black socks, remember they told us that there were Y black socks. So what we could do here is firstly use this quadratic to find possible solutions for Y, and then that will help us with this answer to part B. So using this quadratic, firstly let's write it down, and let's see if we can factorize. So factors of 60 multiplied by 3, that equal 28. That's a tough one. I'm just going to think of some easy ones. So 6 and 10. 6 and 10, just the difference of those is 4. But if we multiply 6 by 3, we would have 18. 18 plus 10 is 28. Okay, so there we go. This is going to factorize into 3y and y, and 3 times 6 and 1 times 10, that would make 28, and they would have to both be negatives. So negative 10 times negative 6 equals positive 60, and this will expand to our quadratic here. Great. So now we have solutions of y. Y equals 10 over 3 or y equals 6. And remember what we're talking about here, we're talking about socks. So that impacts what answer we should look for here. We shouldn't really be looking for a fraction of a sock. Okay, it's possible if Joshua was cutting his socks up and leaving thirds of his socks in his drawer, but realistically, we're expecting there to be a whole number of black socks. So we're taking y equal to 6 here. So therefore, there are 6 black socks in the drawer, as 10 over 3 is not applicable. So then we can also say the total number of socks is 6 plus 5, because we had 5 white socks. So that's 11. So then the probability that he takes 2 black socks, this will be, or let's write that as the probability of black and then a black sock. This will be the probability of 1 black sock, or the first black socks, is 6 over 11, multiplied by the probability of the second black sock. Well, that we'd only have 5 black socks left and 10 total socks. So this will be 6 over 11 times 5 over 10. This simplifies. So 5 over 10 you could write as a half actually. So this would be 6 over 22. And that simplifies further. So divided by 2, and this would be 3 over 11. And that's my final answer for the probability that he takes 2 black socks, 3 over 11. Okay, that was 3 marks. And question 90, what number was this? 93 for a total of 7 marks. On to 94. 94 says the population of a city increased by 5.2% for the year 2014. At the beginning of 2015, the population of the city was 1,560,000. Lynn assumes that the population will continue to increase at a constant rate of 5.2% each year. Use Lynn's assumption to estimate the population of the city at the beginning of 2017. Give your answer correct to 3 significant figures. Okay, so if we're increasing by 5.2% each year, we could use the compound interest formula, which still applies in this case because we're going up by a certain percentage each year. So the compound interest formula says the final amount is equal to what we started with, multiplied by 1 plus the rate to the power of the number of years, or the number of periods. So in this case, at the beginning of 2015, the population was 1,560,000. So that's going to be our starting amount, or our principal, we'd usually call that with compound interest. Our rate is 5.2%. We need to change that to a decimal firstly. So this is 0.052. Add that to 1, this will be 1.052. And the number of years, well, we've started at the start of 2015 and we're looking for the population at the beginning of 2017. So that's 2 years, 2015, 2016. So T there is 2. Okay, and then we can solve this and we'll get our ending population, or the population at the beginning of 2017. So let's put that in. So 1,560 multiplied by 1.052 to the power of 2. And we get 1,726,458. And it said, give your answer correct to 3 significant figures. So then we need to round that to, looking at the 4th significant figure, which is the 6, that means we need to round up the 2 to a 3. So this will be 1,730,000. So I might just write that rounded figure. So approximately 1,730,000 for a final answer there. Part B. 1 says, use Lynn's assumption to work out the year in which the population of the city will reach 2 million. Remember, her assumption was that the population will continue to increase at a constant rate. So using that idea, we can kind of use this equation again, but reverse it. So our ending population is 2 million. Our current population is 1,560,000. Multiply that by 1.052, and then our unknown here is t, the number of periods. So then we need to solve this equation for t. So firstly, divide by 1,560,000. It's the first step. So 2 million divided by 1,560,000, and I get 1.28, etc. So then we have 1.052 to the power of t equal to this number here, 1.28, and so on. And then you can use trial and error to find what t is. So try a number of different numbers. So we could try 1.052 to the power of 4. Let's try that first. So 4 years. You can see it's not quite 1.28. So let's try 1.052 to the power of 5, and we get 1.288. And you can see here that's as close as we're going to get. We go up to 6, it's going to be more than what we currently have, and it's much closer than 1.22. So the estimate here is 5 years. So 1.052 to the power of 5 is approximately 1.288, and that's as close as we're going to get. So the question said, work out the year in which the population will reach 2 million. That will be in the 5th year after 2015, so that's going to be 2020. And I guess that's another reason why it doesn't exactly equal this number, because the question says in which year the population will reach 2 million. So it doesn't say, you know, after how many years, it's within that year. Okay, anyways, part 2 says, if Lynn's assumption about the rate of increase of the population is too low, how might this affect your answer to B1? Well, if the rate of increase is higher, that means the population is growing faster. That means it might reach 2 million sooner than 2020. So let's see if we can write that in a sentence or two. So the population may reach 2 mil sooner than 2020. And that was part B for 3 marks, and total for that question should be 6 marks for question 94. Okay, so I guess that was a little error there. Okay, on to question 95. Question 95 gives us a diagram. It says B, C, and D are points on the circumference of a circle center O. BOD is a diameter of the circle. AO equals 7 centimeters. Angle ABO equals 90 centimeters. Angle OAB equals 35 centimeters. Angle DBC equals 70 centimeters. So all of that is marked on the diagram. Explain why angle BCD equals 90. So angle BCD is in here. Okay, so they tell us that BOD is a diameter of the circle, so this line here. So that is a circle theorem that you need to know. The angle in a semicircle, if you have a diameter and 2 lines joining the circumference from that diameter, the angle is always going to be 90 degrees. And that's called the angle in a semicircle theorem. So we can just write that down. So angle in a semicircle theorem. Angles are always 90 degrees. Okay, so that was part A. Part B says calculate the length of BC, give your answer correct to 3 significant figures. So BC is this one here. Okay, and we don't have any of the lengths in this triangle BDC, but we have one length over here of AO, and this is also a right angle triangle, so we can use that to work out the length BO, the other leg of this right angle triangle here. Once we have BO, well, we know that this is the center, so that would be the radius, and then we can work out the diameter, then we'll have the length in this triangle BDC. So let's go ahead and use this information. Well, this is angle 35, and this is length 7 centimeters, that's the hypotenuse, so we can use a trigonometric ratio to work out BO. So which one would we use? Well, we've got the angle opposite this side and the hypotenuse, So then we're going to use sine, because sine of 35 will equal the opposite side over the hypotenuse. So then we can say that sine of 35 degrees equals the opposite side, BO, over the hypotenuse, which was 7. So therefore, BO is going to equal sine of 35 multiplied by 7. Let's put that into a calculator. Sine of 35 multiplied by 7. I get 4.015. And this is also the radius of the circle. So let's say radius equals 4.015. And then therefore the diameter, which is also dB, is 2 times that. So dB equals 2 times 4.015 equals, let's do 2 times that answer, 8.03, and so on. And now we have this length here, dB, of this right angle triangle. That's the hypotenuse of this triangle here. We can use a different trigonometric ratio to work out BC. So this is now the adjacent side to this angle. So which trigonometric ratio should we use? Well, the cosine relates the adjacent side and the hypotenuse. So we're going to do the cosine of 70 equals BC over dB. So cosine of 70 equals BC divided by the diameter, which we found, 8.03. And then let's use this to find out BC. So BC is going to be cosine of 70 multiplied by 8.03. Let's put that in. So cosine of 70 multiplied by our previous answer, and I get 2.746 and so on. 2.746. And the question said round to 3 significant figures. So to round this off, we would get 2.75 centimeters. And that was for 4 marks for question 95. On to 96. 96 says the diagram shows a trapezium ABCD and 2 identical semicircles. The center of each semicircle is on DC. Work out the area of the shaded region. Give your answer correct to 3 significant figures. Okay, so if we're looking for the shaded area in here, we can work out the area of this trapezium and take away the area of those circles. So usually with these questions where they say work out the shaded region, you want the total area subtract the unshaded shape. So the problem here then is working out the area of that circle, really, because the trapezium, you should be okay with working out the area of a trapezium. You should know the formula. It's A plus B times H divided by 2. A and B are the top and bottom sides. H is the height. We have all of those. So you should be okay with working out the area of that trapezium. So actually, let's go ahead and do that first. So the area of the trapezium, this equals A, which is 12, plus B, which is 28, multiplied by the height, 14, divided by 2. So 12 plus 28, that's 40. And 14 divided by 2 is 7, so we'd have 40 times 7. 4 times 7 is 28, so this would be 280 centimeters squared. Let's have a look at this circle here now. They say that they are 2 identical semicircles. So in effect, we have one whole circle here with these 2 semicircles. So we're basically just trying to work out the area of one whole circle. So what do we need to do that? We need a radius. If this length is 12 centimeters, then that means each diameter of the circles is half of that. So this would be a diameter of 6 centimeters. And if the diameter is 6 centimeters, then the radius must be 3 centimeters. Now, okay, if I want to be nitpicky on this question, it doesn't say that these circles are exactly within this length here. So it doesn't say if there's a gap. Like there might be a gap between these 2 circles, and then you can't figure out the radius. But we're assuming that they are exactly touching at these points. So that's a slight criticism of this question. I don't think there's quite enough detail. But anyways, making that assumption, we've got a radius of 3 centimeters. We can work out the area. So the area of a circle, you need to know this. You need to know this formula. It is pi r squared. That's something you need to memorize. So r is 3, therefore this is going to be 9 pi centimeters squared for the area of the circle. So then the shaded region is going to be the area of the trapezium, subtract the area of the circle. So 280 subtract 9 pi. Let's put that into a calculator. 280 subtract 9 times pi. And I get 251.725. Rounding to 3 significant figures, this would be 252. So let's write down the non-rounded answer first, and then round that off to 252 to 3 significant figures. Alright, so that's my final answer there for question 96 for 4 marks. Question 97 says the diagram shows a regular pentagon ABCDE. The pentagon is divided into 5 isosceles triangles. OA equals OB equals OC equals OD equals OE equals 6 meters. Okay, so there are all of these lengths in here around O, and they're all equal. It says work out the area of the pentagon, give your answer correct to 1 decimal place. Well, this is going to involve finding the area of one of these triangles. So if these are all equal, so this is 6 meters and they're all 6 meters. We also know that it's a regular pentagon, so these lengths will be the same around the outside. So that means that all of these triangles must be congruent, right? They have the same sides on the inside and the same base lengths. So all of these triangles are congruent. So let's go ahead and write that down first. And that was side, side, side. That's the rule I used there. We can also work out the angle in here, the interior angle of these isosceles triangles. So all of these angles are the same because it's a regular pentagon. So to work that out, we do 360 divided by 5. So angle AOB equals 360 divided by 5. That's 72 degrees. And then to work out the area of this triangle here, or this one, we could use half AB sine C, because we have this angle, we have 2 adjacent sides, and that's all you need to find the area. So the area using half AB sine C, this is going to be half multiplied by 6 times sine of 72. Okay, let's go ahead and put this in. So, well, half of 36 is 18. 18 times 72 is what we're working out. I get an answer of 17.119 and so on. That's the area of one of these triangles, so multiply that by 4 to get the total area of the pentagon. Okay, so multiply this by 5, multiply by 5, and I get 85.595 and so on. So total area, let's go ahead and write that working out down, and I got 85.595, and it said give your answer correct to 1 decimal place, so this would round off to 85.6 meters squared. And that was 4 marks for question 97. We're almost there. Question 98. The diagram shows a solid triangular prism. The prism is made from metal. The density of the metal is 6.6 grams per centimeters cubed. Calculate the mass of the prism. So we have the dimensions of this prism and we have the density. Therefore, we can work out the mass because we know the relationship between those things. So remember, this triangle gives you that relationship. Mass is on the top, density and volume on the bottom. This tells you that mass equals density times volume. So let's go ahead and work out the volume first. So the volume is going to equal the area of this triangle multiplied by the length. So the area of the triangle, base times height divided by 2, effectively 6 times 5, which is 30. So we'd have 30 times 15. 30 times 15 is 3 times 15 is 45, so that'll be 450 centimeters cubed. And then, as we said, mass is density 6.6, and this is in centimeters cubed already, so the units are all fine. 6.6 times 450, that will give us our mass. Let's put that into a calculator, and I get 2,970 grams for the mass of the prism. Okay, that was question 98 for 3 marks. And on to the final question. Wow, on to question 99, finally. Here is a sketch of part of the graph of y equals pq to the power x, where q is greater than 0. The points 0, 5, 2k, and 4, 405 are all on the graph of y equals pq to the power of x. Find the value of k. So for this question, we can use the points on this graph to find some of the variables in this equation first. So for point 0.05, we have x equal to 0 and y equal to 5. So if we plug those into this equation here of y equals pq to the power x, q to the power of 0, that would just be 1. So then we would have y equal p. And if y equals 5, then p is going to equal 5. So what we're saying here is y equals 5. This equals p q to the power of 0. Q to the power of 0 is 1. So therefore p equals 5. So then y equals 5 q to the power x. Now we have the value of p. Let's use the second point on that graph to find q. So using 405, y is 405, x is 4. We have 405 equal to 5 times q to the power 4. 405 divided by 5 will give us q to the power 4. 400 divided by 5, that's 81. So q to the power 4 equals 81. And then q equals the fourth root of 81. Now if you know your powers of 3, you know 3 times 3 is 9, and then 3 squared times 3 squared must be 81. So 3 to the power 4 is 81. So therefore the fourth root of 81 is 3. And we don't have to worry about the negative solution here because they give us the graph. So it's clearly not a negative, it's in the positive area of the y-axis. So q is going to equal 3. And so then therefore y equals 5 times 3 to the power x. Or usually this would be written as 5 times 3 in brackets to the power x. And now let's use this equation to solve for y when x equals 2. So this point x equals 2, we're looking for k. So when x equals 2, y is going to equal 5 times 3 to the power of 2. 5 times 9 is 45. And therefore we have our value of k. So at this point, when x equals 2, the y coordinate is 45, therefore k equals 45. So final answer there, k equals 45 for 4 marks for question 99. We are done, hooray! If you completed this whole paper, give yourself a pat on the back. Well done, awesome work. I myself am pretty impressed that I got through this whole thing. If you haven't seen the whole paper, or if you haven't had a go, the paper's linked in the description. I've gone through the whole thing in the 99 problems playlist, so you can check all that out if you want. But again, congratulations if you finished the whole paper. If you need more revision, check out the rest of the videos on my channel. Please leave a like if you found that useful, subscribe if you want to see more content, and I'll see you in the next one. Bye for now.